Welcome to the penultimate day of National Astronomy Week 2020. And tonight has to be a favourite, exploring the facts, fiction and fascination behind space and Mars science fiction. Now, one benefit we found of moving our usual star parties to this virtual realm has been that we've not had so many constraints geographically. So we're really happy to be welcoming attendees logging in on Zoom here and on YouTube Live across the UK and overseas. Now, as you can see from our fabulous intro video, National Astronomy Week is supported by a group of organisations and networks promoting astronomy and space education for all ages. My name is Sharon Levermont. I work with the UK Association for Science and Discovery Centres and the British Association of Planetaria. And my co-host is Sue Nelson, who is an award-winning science and space journalist, co-host of the Space Boffins podcast and author of Wally Funk's Race for Space. She's a former BBC science correspondent and avid sci-fi fan. So I am thrilled to hand over to you, Sue, for our opening talk.
Thank you. Now, I'm going to give an overview of Mars and science fiction before we get into the real meat of the subject with our other two speakers. And as Sharon said, I definitely have an interest in Mars from both sides of the fence here, from both the science side and the science fiction side. And I'll give you just a brief idea of some of the ways in which I have a connection to Mars, both professionally and on the sci-fi side of things. First of all, I'm maybe somebody's joining this talk who's also done this, but my name is on the surface of Mars, because about 20 years ago, you could register with NASA and have your name engraved on a little chip that went up with one of the Mars rovers. And I've also covered a lot of space missions, particularly reporting, whether it's TV or radio, many of which have gone on to Mars for the BBC and for the European Space Agency. And in terms of the sci-fi aspect of it, I actually walked down the aisle on my wedding day to some of the incidental music from Mars Attacks. It wasn't the theme tune, it was actually the music where, if you remember the female alien with the huge head and the sort of turned up hair, sort of shimmies, it's like a theremin, sort of gliding to the White House. And as my husband pointed out when he realized where that section of music was from, it was actually before she then basically bit off his head and ate him. But I just want you to know that my husband is very much alive, and it did go down really well on the day. On the reporting, though, as you probably know, actually getting to Mars, unlike science fiction, it's really, really hard. And I've done covered so many missions where actually it's as much as gone wrong as it's gone right. Way before, though, I became a reporter, though, the first mission that actually, the spacecraft that failed was a Soviet one, and it was in 1971, so that's almost 50 years ago. It was called Mars 2. And while NASA, I think NASA makes it look easy most of the time with the amount of rovers they've got on Mars, but even NASA has had its difficulties. In 1999, that's one of its most famous failures. Its Mars Climate Orbiter actually effectively crashed and burned because one part of the team used metric measurements, and the other used pounds and feet. So a simple calculation, a simple mistake like that caused a lot of money to effectively go up in smoke. European Space Agency have also had a few issues getting there. In 2003, I was one of those journalists who was actually sat on the floor of the press conference waiting for Beagle 2 to effectively phone home. And while for years, everyone thought that too had crashed. Actually, it hadn't. It had landed, it was intact, but one of its solar panels hadn't fully opened, and so it wasn't powered up to actually communicate for the rest of it. And more recently, just a couple of years ago in 2016, Schiaparelli lander crashed into the Martian surface at 340 miles an hour. So you really have to sort of suspend disbelief today when it comes to science fiction in terms of thinking how to get human beings safely to Mars when there is such a high failure rate. And that failure rate, incidentally, of successful missions in terms of landing is actually around 50%. That's actually improved. A short while ago, it was 60% failure rate. It's now 50%. But that's still, if you were a human being wanting to go to Mars, a 1 in 2 chance at today's rates is quite a tough one. Science fiction, though, of course, has had much more success getting there or sending people from Mars to us. And I'm just going to skim through just some of my favorite sort of sci-fi examples of books and films that have actually, have got Mars in them. War of the Worlds, you can't go without War of the Worlds. And I know one of my speakers is going to go into a few more details about it. And in fact, I brought this, I thought I'd show you this. War of the Worlds is the reason I bought this totally impractical and useless Philip Stark designed lemon squeezer. It's useless because if you squeeze your lemon on top, both the pips and the lemon juice go actually nowhere. So, but I bought it because it reminded me of the craft, the tripod legs that the aliens, the invaders from Mars, when they came to Earth in H.G. Wells's War of the Worlds. So it was worth every penny just for that. There have been some extraordinary writers that have covered Mars. Philip K. Dick, Ray Bradbury, Arthur C. Clarke, Andy Weir. In fact, The Martian is on TV later this evening. And for me, Andy Weir's book was a revelation, both the book and the film, because it was a believable and very recognizable scenario of what it's like to be on the Martian surface, apart from the radiation. You had to suspend disbelief in that because the radiation would kill most people. Starship Troopers, now that film, it's a bit of a cult film, that one. I'm not a big fan of that. I just think it's so ludicrous, but loads of people love it. That was set on Mars. My favourites, though, I think have got to be the Total Recall, both the book, which was Philip K. Dick, We Can Remember It For You, wholesale, and the 2 films, the Arnie one in the 90s, and then the one with Colin Farrell that was mostly set on Earth in 2012. That's a standout for me because it's about the reliability of memory, but particularly I think with the film in the Arnie film, because it showed you how dangerous it was if your habitat on Mars was fractured in some way, and the danger of actually being out on the Martian surface. I've put various books behind me, as you can probably see, strategically placed, including one of the speakers there, of Roberts. The Watchman, is that because Dr. Manhattan actually sort of exiles himself to Mars in that one. But I thought I'd just mention that the film, if you've not seen it, it's an old film from the 70s, Capricorn 1. This was about a faked landing on Mars, where NASA basically realized that the mission wasn't going to succeed, so they decided to fake the entire thing with a film set. And I think this is quite an important film in relation to Mars, because it's probably one of the reasons that so many people then believed, sort of around that period onwards, that the moon landings were also a hoax. And some people still do think that. But it's got a lot of nice little sci-fi trivia about that film as well. In Capricorn 1, you've got O.J. Simpson, who, for anybody probably over the age of 30 or 40 watching this, who was an American football player, but then was later, became an actor. He was in the sort of airplane films, I think, or something like that. And then he was later jailed for murder. It also had Telly Savalas in, who later then became Kojak, also played Blofeld in one of the Bond films, on Her Majesty's Secret Service. And if you're a big fan of Friends, he was actually Jennifer Aniston's godfather in real life. and this is my favorite connection. Capricorn 1 contains James Brolin. He plays one of the astronauts, I think. Well, his son, Josh Brolin, is Thanos in the Avengers. Now, how cool is that? And I'm going to end on a book that I realized I've got quite a few books relating to Mars. This one is an unlikely partnering. It's actually written by Buzz Aldrin. It was in the 90s with a science fiction writer, John Barnes, called Encounter with Tiber. And it's even autographed from him as well, because I got to review it for The Independent, I think. And I actually really enjoyed this book at the time, and it does involve a lot about human beings being on Mars, because as you may know, Buzz Aldrin is a massive Mars fan. He's worked out a lot of the orbits, the orbits that will get human beings from the Earth to Mars, often using, in a way that actually Artemis and the Moon is sort of ongoing now, by using, not going directly from Earth, but going from a satellite that would take you to another satellite out of Mars. And this book, which I say, I don't know whether it stands the test of time, but it's actually got quite a lot of little details, sometimes of the orbit, sometimes it's even got the shuttle bailout procedure, the spacecraft that's in it. So it's a real combination of science and science fiction by, and he'll hate me for saying this, the second man, to walk on the moon. So they're just a few of my favorites. You're going to hear a lot more from our two speakers. So I will be with you again after both speakers have given their talks, and we'll be facilitating the question and answer session. So anything you've got, question as they're talking, type it in or wait to the end, and I look forward to seeing you then and hopefully getting some of your questions answered. And in the meantime, I will now hand over to Sharon.
Thank you, Sue. I've literally been writing down like, oh, that one, I haven't heard of that one. Great. So much follow fodder, I think. Thank you so much. Thank you for that introduction. And I'd like to introduce as well our first speaker, who is Robert Walsh. Now, he is the professor of solar physics at the University of Central Lancashire, which everyone calls UCLan. He's a leading expert in understanding observations of our closest star, and he's actually responsible for the sun. Now, I don't know if anyone was with us on Wednesday where we saw some of Luke Jerram's artworks, but this is a 7-meter sizzling 3D sun which premiered at Lightpool, and I can't wait to see it in person, Robert, when this pesky virus gets under control. But right now, with other UCLan researchers, Robert has written a very popular science book entitled Unmasked: The Science of Superheroes. This is him here. So I'm going to leave it over to you as an absolute expert in this to take us on a journey about aliens and sci-fi. Over to you, Robert.
Thanks so much, Sharon. I'll just hopefully can share my screen here and you can see where we're up to. There we go. And thank you for having me here this evening. It's great to be able to tell you a wee bit about what I've called here Unmasking the Martians, sort of a run through what it would like to try and unmask some possible alien superheroes and the sci-fi implications thereof. We don't have much time, but let's see what we can do over the next 15 minutes or so. You know, I say the word Martian to you, I wonder what you immediately think. Sue's already mentioned to us that probably you would maybe initially think of War of the Worlds, the novel serialized back in 1897, would you believe, written by H.G. Wells, where this is the sort of the conflict between humankind and an extraterrestrial race. They invaded southern England. They didn't seem to come up to where I am in Preston. Maybe they didn't like the north of England or the weather or something. But that book, that idea and that concept really has grown so much. Really, you know, you've got here an image of Orson Welles and he had an American radio drama where he adapted and adopted the H.G. Wells story. He broadcast it live on Halloween night, the 30th of October, 1938, and the episode has become famous for allegedly causing panic among the listening public that actually a Martian invasion was going to take place. If you go on from further than that, and Sue's mentioned some aspects of these things, the iconic images that you get when you think of Mars and Martian spacecraft, the top bottom left corner there of the 1953 movie version, where you have these death rays spitting out, the light and lasers and destroying everything in their path. And of course, we have Jeff Wayne's musical version of War of the Worlds. It debuted in 1978, and even now still goes on arena tours, or well, it will once everything gets back to some degree of normality. But you can probably hear the music of that in your head. It's the chances of anything coming from Mars are 1,000,000 to 1, and yet they still come. So we have our Martian neighbors wanting to dominate us here on Earth. It seems ingrained in our popular culture. It's there in our psyche, and as Sue has already mentioned about Mars attacks, these little green men heading our way, epitomized in that Tim Burton movie in 1996. Now, sometimes in the comic books, they actually turn that around and they make the Martian the superhero. Probably most famously, DC's Martian Manhunter is shown here in the middle of our screen. He has the ability to change his appearance to look human and blend in with the rest of us. And it's already been a plug here from Sharon tonight, but I was fortunate enough to just release, just before the start of the first lockdown, a popular science book with colleagues at the University of Central Lancashire called Unmasked: The Science of Superheroes. Very passionate to try and use the superhero genre as a vehicle to engage people with science. Being the astronomer, I was given the superhero alien gig, and each of us was drawn as the superhero. This is what I was drawn to be. I'm not too sure whether it's a good likeness or not, but I suppose since I'm from Ireland, it's okay to be green. Yeah. But without a second thought, characters in these stories, in our comic books, on our cinema screens, they often just accept that Martian or extraterrestrial life actually exists. It's not just commonplace, it's everywhere throughout the cosmos. These superhero exploits introduce us to a universe really teeming not just with life, but with intelligent life in every shape and form, and possessing a technology that's far superior to our own. So maybe we could ask ourselves this evening, what are the chances that alien life could evolve on Mars or elsewhere in the galaxy? Would that life be intelligent? And then how does Mars fit into that? Well, it was back in the 1960s that the astronomer Frank Drake put forward a very simple way to try and estimate the likely number of intelligent extraterrestrial species that may be in the Milky Way that also could be actively communicating out into space. I suppose the premise really is the vastness of space a busy or a very lonely place? Frank postulated that what's now known as the Drake equation, it's there on the whiteboard behind him, something which is at the basic level a sort of extraterrestrial recipe for life. It seems to give us a sort of an educated guess on the possible number of intelligent civilizations out there in the Milky Way. Let me draw it again for you here. There's lots of elements to it, and I want to quickly and swiftly go through each and try and understand if we can unpick some of the latest estimates, latest values for each important ingredient in this alien recipe, where N is the number of intelligent civilizations that could be out there. Let's look at the first parameter. It's termed R, and it's defined as the birth rate of suitable stars in the Milky Way, measured as the number of stars born per year. It's not a case that stars have simply existed after the Big Bang, or all stars are the same. Galaxies are incredibly large collections of different types of stars. And one way of classifying this rich variety that we observe in the night sky is use something called an Hertzsprung-Russell diagram, or an HR diagram. We have it here in a schematic form where the star's temperature is on the horizontal axis in Kelvin, and how bright the star is on the vertical axis. That's the luminosity. And I suppose the HR diagram is used to allow us to follow the evolution of stars as they burn up their fuel, as they evolve from one type to another. And if you look, you can see there in the center of the HR diagram, there's a sort of an ordinary bog standard star. It's not too bright, it's not too hot, and that's our sun. It's the one data point that we do have where we know that life exists. For a suitable star for this value of R, you probably want one that's stable for a considerable period of time, probably hundreds of millions of years, doesn't go supernova. Maybe there could be a double star in there, but let's for the moment go with some of the latest estimates, are that there's about 3 stars per year. We'll put R as our first value, our first ingredient, as a value of 3. And we're now underway. The next ingredient, next parameter, is FP, which is the fraction of stars that have planetary systems associated with them. And that's really, folks, where big changes have been happening recently, a rapid acceleration of the detection of exoplanets, planets around other stars. There are several ways of doing that, but the most popular and well-used and, I suppose, successful method is a sort of a planetary hide and seek. It's known as the transit method, where basically we have a planet travels in front of the star as is viewed from your position as an observer. And then there's a tiny but a measurable dip in the overall brightness of that star. There's some very successful missions have tackled this method, and we do it from the ground as well, of course. Here's an image from NASA's archive, which shows a vast range of what they think the planets are like that they've detected around other stars. In fact, if you look onto the NASA's exoplanetary archive this afternoon, which is what I did, it's now ranked at 4,306 detected exoplanets, with another 2,394 possible exoplanetary candidates. So it's an awful lot out there, and that sort of really allows us to be generous here tonight. Let's be generous and say that FP is equal to 1. That is, that if there is a star, then there's at least one planet rotating or orbiting around that body. The next parameter is all to do about not just having exoplanets, but where they exist in the star's habitable zone. That's the spherical region of space around a star where the temperature and atmospheric pressure on the exoplanet that resides in that zone is such that liquid water can be sustained at the planetary surface. And this is where things start to get a wee bit tricky. If you look at the exoplanets that we have detected so far, about a quarter of them are gas giants, while a further 50% of them are hot Jupiters. They're Jupiter-sized planets with orbits of days very tight into their host star. And then you get the stellar wind coming out from the star impacting on that planet. So that would be purely a selection effect given our current instrumentation and levels of sensitivity as we observe these exoworlds. But we probably could estimate around about 20%, say, of the planets around other stars sit in that habitable zone. So we'll put our parameter at 0.2. Then the Drake equation takes us on to the actual extraterrestrials themselves, with the parameter FL, which is defined as really the fraction of habitable planets where life comes into being. And this is largely unknown, because currently, as I've said, we only have one data point, us, here on Earth. But that said, that on Earth we have life which is such rich diversity that would seem to suggest that if the conditions are even favorable or right, then life could arise. So again, I'm going to be optimistic tonight and set that parameter equal to 1. That's if if the planet is potentially habitable, the life will somehow find a way, as you know from other science fiction movies. Then we come on to another ingredient, which really has to do with the extent to which the alien life forms themselves want or could be detected. So the next parameter, Fi, is all about not just having life, but having intelligent life. Now, what does intelligent mean? Actually, defining that can be quite difficult. What's a definition for the living things here on planet Earth? What yardstick would you use to rank plants against insects or reptiles against mammals? You know, are plants intelligent? Well, just think of Groot from Guardians of the Galaxy for one. You can have an argument with him about what it means to be intelligent. On the other hand, it could be argued that maybe the use of tools to manipulate and change your habitat around you shows that the life form has an understanding of how their environment could be altered for their benefit. See, on Earth, we've got crows that have incredible skills with little sticks to get insects out of tree bark. There's even been examples of octopuses using coconut shells as armor and protection. Or maybe you think, no, you also need to have these alien life forms communicating with one another, a form of language that helps to build groups or societies of creatures living and sort of working together. Examples here on Earth, apart from ourselves, would be dolphins. They have a very complex set of clicks and whistles that help them to communicate with other members of their species. I suppose the argument would be that maybe over millions of years, life would always evolve to become intelligent, at least in some of these definitions. And so therefore, let me be generous again and put this parameter also equal to 1, i.e. it's going to occur 100% of the time. But then you don't only want just intelligent life, but then you want life that's mature enough that it's succeeded in developing technology and a desire to communicate outside to other worlds. That's the parameter FC. Now, of course, here on Earth, we've been shouting, "I'm here," for nearly a century now. Our accumulated radio communications have been leaking out from Earth in an ever-expanding bubble of radio noise, inflating out at the speed of light, really, waiting for someone to detect it. Now, maybe unlike some of the superhero stories, and we've already mentioned his name tonight, let's assume that there's no Thanoses out there who want to click their fingers, or evil Skrulls that want to come down and invade us. But rather, they're intelligent civilizations that are civil, peace-loving, and simply want to have a nice chat with us. So I'm going to put this parameter also equal to 1. Yeah, they always do want to communicate. And then we come to our final ingredient in our alien recipe. The parameter L is defined as the average number of years that a technologically advanced civilization will actually last. Essentially, this is asking how long it would be before your alien culture will either destroy itself, let's say a nuclear war, or will disappear by some other means, asteroid strike, or dare I say it, a devastating global health epidemic. You need to think of Superman. His home planet of Krypton was on the point of destruction from overmining the inner core, that actually his escape from that dying planet brought him to Earth in the first place. So estimates for L range from the pessimistic, very short periods of time, hundreds of years, just like the modern empires on Earth, to wildly optimistic. Maybe a civilization is so developed that it can overcome all possible threats and exist for hundreds of thousands of years. So it's quite arbitrary, but once again, let's be optimistic and set L to be 100,000, just for our calculation tonight. So what are the scores on the doors? Well, here I've put a table of optimistic numbers with all the parameters listed. We've got the birth rate of stars and habitable zone numbers and where we want to communicate, or are we doomed? And if you multiply those all together, you get a Brucey bonus of 60,000 for the parameter n, indicating your galaxy is teeming with life for us to find. But if you be a bit more pessimistic, maybe there's less birth rate of stars, or the habitable zones have less planets in them. Intelligent life only happens in maybe not all the time, but only a small percentage, 3% of the time. And maybe your civilizations only last for about 5,000 years. Then you multiply that all together and you get a value of 1. And then maybe we are alone in this part of the universe. So is the Drake equation flawed? Yes, it is. But maybe that's not important. In fact, the number n maybe isn't important in itself, but rather the thought process is important that we've gone through to try and understand how intelligent life could flourish out there somewhere. And that leads me on to Mars. Because with all this week and all the talks that have been happening here at the National Astronomy Week, and I would encourage you to go back and check them out, because it's been an excellent series. By some definitions, due to Mars's elliptical orbit, Mars is sometimes in the sun's habitable zone and then sometimes outside of it, in for maybe about 80%, outside for about 20%, I think. Still a point of discussion, but that's where Mars we think is sitting. You've maybe heard this week's about concerted efforts of orbiting spacecraft and landers seeking for evidence for life that might have been there, or maybe is still there in some microbial form present on the planet. And if that was the case, when looking at the Drake equation, confirmation of that would drastically increase the odds that life is abundant across our universe. But also, the absence of life would also be is equally interesting. Why hasn't it occurred? What does it mean if Earth is singular and we are alone? The popularity of Martian visitors and alien superheroes, invading Earth and then saving our planet, is not going to diminish anytime soon. However, I hope, as we've seen, as we've explored together tonight, the conditions for life to have an opportunity to occur, let alone flourish, can be formidable indeed. And I haven't even begun to mention the physics of interstellar travel and the challenges that throws up as you want to go from one star to another. But maybe until then, we'll just have to be content with dreaming about exoplanetary expeditions through the adventures of your favorite Martians and your favorite extraterrestrial superheroes. That's all for this part of this evening, and I thank you very much for listening.
Thank you very much, Robert, for that. And quite a few questions have, let me just get this back into, there are quite a few questions have come in for you, which we will ask coming up relating to parts of your talk there. But before we get into that, let's move on to Elizabeth Stanway. Elizabeth is an Associate Professor of Astronomy at the University of Warwick, and she's going to discuss inhabiting Mars in both science and science fiction. Elizabeth.
Hello, pleased to meet you. I am going to indeed be talking about how Mars is inhabited in the different science fiction that we all enjoy and know and love. I'm hoping that you can all see my slides by this point. And I'm going to be telling you a little bit about certain aspects of inhabiting Mars. As always, there is plenty of opportunity and scope to explore this subject and relatively little time available. But I do want to make an important point, which I always do when I talk about science and science fiction, which is that sci-fi is fiction. It does prioritize stories first and foremost, and there's nothing wrong with that. But I also want to make the point that having accurate science in the film can not only lead to a good story, but also to a more believable one which is open to suspension of disbelief and which enables us to really engage with the narrative that we're viewing. So as we've already heard, intelligent life on Mars may once have appeared probable. It's fair to say that we no longer think that 3-meter tall, 6-limbed aliens are necessarily likely to be occurring on Mars. And even by the 1960s, we already had a fairly good grasp of that. So even by the time Thunderbirds Are Go was filmed in 1966, people already knew that Mars was a very hostile environment. So instead of alien princesses in need of rescue, we had Martian rock snakes shooting balls of lava through a vacuum. So we've known now for really quite a long time that the environment of Mars is really quite hostile. Its surface is very arid, its atmosphere is very thin and is full of carbon dioxide, and the temperatures are very low. Given that very hostile environment, we can ask the question, what do humans need to survive on that surface? And that's the question I'm hoping to address. We're going to consider this by looking at a film in which a human astronaut is stranded accidentally on Mars at the end of his mission. And those of you who are fans of Hollywood blockbusters may well have a good idea of which film I'm talking about. And I'm willing to take a small bet that it may not be this one. So Robinson Crusoe on Mars from 1964 was based on an 18th century novel because the questions that we have to ask about human habitation are really universal. How does a human being survive when isolated and left to use the resources that they have with them or which they can find in their natural environment? Strikingly, this film makes the strong claim that the film is scientifically authentic, only one step ahead of present-day reality. Well, back in 1964, that was certainly true, but of course time has moved on. So it's a fun approach to compare two films with the same scenario, but which were filmed 50 years apart and which demonstrate how our understanding has changed. So I'll also talk about the film we've already heard about, The Martian from 2015. And I hope or think that this was the film many of you would have been thinking of when I described it. So in both films, our NASA commander Kit Davis in Robinson Crusoe on Mars and astronaut Mark Watney in The Martian had to think through the necessities of life, and perhaps the most fundamental, the one we rely on the most for life itself, and which yet we take the most for granted here on Earth, is simply the air we need to breathe. In Robinson Crusoe on Mars, our astronaut really faced a steep struggle with this. As you can see, the technology which we knew of at the time involved really quite bulky air packs, quite limited supplies that could be transported. And as a result, the astronaut had to find a local source of oxygen. In this particular case, the film hypothesized that maybe there were rocks which could release oxygen and flammable gases when heated. Well, it sounds plausible. We certainly know of rocks like coal that are flammable when they're heated, but all of those heating and burning processes that we know of here on Earth are reliant on having oxygen around to begin with. Heating material, combusting or oxidizing it is a process that takes in oxygen rather than releases it. So unfortunately, we're unlikely to be able to cook Martian rocks in order to refill our oxygen cylinders. Now, as of 2015, of course, we had a much clearer picture of this. And astronaut Mark Watney in The Martian was left with a fully equipped module that was designed to support human habitation. And it was equipped with a chemical oxygenator based on NASA technology to split carbon dioxide. That technology is now well established in the labs, and indeed Martian landers have carried experiments which have taken the carbon dioxide in the Martian atmosphere and split it to produce oxygen and inert materials that could be used for other processes. But even if we have our air to breathe, what's our next necessity? Well, here on Earth, and for pretty much anywhere human beings are going to survive, it has to be water to drink. The habitable zone that Robert told us about is predicated on the fact that all life as we know it likely needs some form of liquid water. Now, as of 2015, the Martian film described a really quite complex, but nonetheless innovative chemical process by which hydrazine rocket fuel, made up of nitrogen and hydrogen, was split by a chemical reaction with iridium, a metal that you find in modern electronics. That produced oxygen, and the oxygen could then, the oxygen which had already been produced could be burnt with the hydrogen to create large volumes of water. So our modern view of securing water on Mars is largely a technological one. It relies on us understanding and pushing for the chemical processes that can be devised by scientists. By contrast, of course, back in 1965, we had less of an idea of this. So astronaut Kit Draper encountered underground water on Mars, heated by aerothermal energy. At the time, we didn't realize quite how tectonically inert Mars was. And so Draper was able to find underground water. Interestingly, this is an idea that may well be returning to scientific orthodoxy. As recently as late September, ESA, the European Space Agency, released a survey and study that demonstrated the existence of underground lakes on Mars. However, unlike those which our astronaut bathed in, these lakes will probably be very cold, and they're certainly very deeply buried. But let's say we have Mars with water, with air. What's next? Well, the next basic of life for most people, and for many of us, our overriding motivation is food to eat. Here, the 1965 view of Mars certainly had an advantage. If you have warm thermal springs, the kind of thermally heated environment that leads to chemical reactions occurring, you may well have some form of life. And Robinson Crusoe on Mars hypothesized a type of native waterweed that could be farmed through a form of hydroponics. Hydroponics, of course, is a technology that is quite widely used and which has certainly been discussed in the context of producing food for astronauts. In fact, this approach, having to farm the available resources, is actually quite similar to that which was adopted by the astronaut Mark Watney in The Martian. In this, he identified seed potatoes amongst the food supplies that had been left behind with him on Mars, and was able to use human waste to fertilize soil from which the water had washed out the harmful chemicals in order to grow potatoes on Mars. Again, growing food on Mars is very much an active area of research, and this is based on very robust science. Indeed, NASA has several programs to develop greenhouses and artificial enclosed environments that would enable food to be grown in Martian or Mars-like conditions with low light levels and cool temperatures. Indeed, the kind of light levels and temperatures that we only find on Earth in remote areas, such as northern Canada, the Nunavut region, where a greenhouse has been set up specifically to try and reproduce the conditions on Mars. Finally, then, I'm just going to touch on the need for heat and shelter. Here, 2015's Martian astronaut had a definite advantage. He was left with a settlement that was designed for human habitation that stretched into weeks or months. But you might notice that this habitation module has extremely thick walls. The reason for this is the need in both science and science fiction to protect our astronauts against the very low temperatures and also against the bombardment of radiation on Earth. Curiously then, again, we find that the 1965 view of Mars, in which the astronaut adopted a cave as a shelter, may indeed turn out to be a return to scientific thought processes. Because as over time, this idea of living in caves, of using the thermal and radiation insulation of cave walls, keeps recurring. And just in August, there was an article in Forbes magazine which advocated humans on Mars becoming cave dwellers. Now, surviving on Mars is probably feasible. As I've said, there are problems. There are these necessities of life, but there are also solutions that are either understood or hypothesized or have been explored in science or science fiction over the years, even if that is only going to be possible for relatively small numbers of people. Importantly, though, this form of science fiction, and I focused on 2 films, but I could have mentioned The Great Domed Cities in Dan Dare, Pilot of the Future, for example, or indeed in the settlements in Total Recall. This kind of science fiction gives us a playground in which we can explore ideas regarding human settlement on other worlds. We can troubleshoot those ideas, we can talk about the science that underlies them, and thinking through those problems now could well affect the lives of real astronauts in the future. That's all I really wanted to say to you, and I believe that we will be taking questions now for both me and for Robert.
Thank you very much, Elizabeth. Plenty of questions coming in that cover both the science and the science fiction. I will start by answering the easiest ones, because I'm going to leave the more difficult ones to you two. Is that we've had a couple of questions that have been answered directly about craters. What about Mars have craters? Yes, thousands of them. And somebody didn't want to give their name. That's absolutely fine. Said, have we named any craters on Mars? Now I'm going to quickly answer that because I love this. Yes, they're mostly named after place names, although there is the odd crater that's named after an astronomer or scientist like Isaac Newton and Copernicus. But these are my particular favorites. There are, names from all over Peru, Norway, Ireland. There's a crater called Wicklow, but I think it's the English ones that I think are slightly hysterical because there's something about their names that just doesn't sound like it should be a crater on Mars. We have a crater on Mars called Crew, Maidstone, Woking, Swanage, and my favorite, because I thought at first it was an animal, but it is actually a place name. There is a crater on Mars called Badger. Right, so let's get on to, we had a question from Justin, and I think considering you've got some Kim Stanley Robinson books on your shelf, Elizabeth, I think you should be the one to answer this. The question was, his trilogy, does it do a better job scientifically or politically?
That's a very good question, and it links into the wider question of whether terraforming Mars will ever become a science fact, which I see we've also had another question from Jeff in the Q&A about. really, terraforming is one of those ideas that's incredibly attractive to us as human beings. We'd like to make Mars better for ourselves. It is going to be extremely difficult. There have been suggestions from Arthur C. Clarke in the 1950s and Isaac Asimov. Many suggestions involve detonating nuclear weapons on Mars. If I recall correctly, Kim Stanley Robinson's involved melting the permafrost in Mars using nuclear weapons. Now, it's fair to say that since the 1990s, when those books were written, our attitudes towards that kind of very destructive and invasive approach to an environment have become more hesitant. And it's arguable that the structure of Mars could cause problems with that kind of approach. Having said that, I wouldn't rule it out. It would take an enormous amount of willpower and money, and that's where the political aspect of the Mars trilogy comes in. And that is something that Kim Stanley Robinson does write extremely well. So I wouldn't rule it out, but at the same time, I wouldn't necessarily rule it in. And it's worth mentioning that where science fiction does talk about aliens areoforming Earth instead, converting Earth into a Mars-like environment, we've been less than happy with the results. So is it really right for us to impose that on another world?
Thank you.
Excellent question.
Elizabeth. Right. There's a question here which I think maybe Robert should answer, because you had the Drake equation on one of your slides about life. And Carol Bryan's question was, how did Drake define life when he devised his equation?
I do think he defined it in the absolute most general sense, i.e. any sort of form of individual life, whether it be microbes through to fully fledged, multicellular organisms. Remember, as I said, the Drake equation is a thought experiment in many respects of trying to bring those various elements together. And I suppose if you have just life as microbes, then all the other bits of the equation start to fall away and become much smaller numbers, and your chances of detecting intelligent life becomes increasingly small. So I think he was generally thinking, well, just this, see what's out there. And I suppose that's also helps with the flexibility of the equation, because it allows you to sort of have a whole range of parameter values, including from maybe what he thought microbes right up to intelligent multicellular beings.
Thank you. Now, Eleanor Phillips has asked a couple of questions. I think one of them was partly answered earlier about how we classify intelligent life. But the other question about, would extraterrestrial life be able to live in different conditions other than humans? And if so, would it be possible that we're looking in the wrong places for life? Or is it still possible that some life forms live in a variety of different planet habitats? I love that question because it brings up so many wonderful possibilities in our solar system. So both Elizabeth and Robert, I think, should have a go at answering that question. Who wants
Elizabeth, you want to go first there, Elizabeth?
Oh, certainly. Yes, so could life take well, this year, and there are some types of chemical compounds which may support life. For example, there's been a lot of discussion about silicon, which as an element in the same periodic table column as carbon has many of the same chemical properties. However, silicon-based life would be more challenging in terms of its energy requirements and its stability than carbon. And as a result, the existence of carbon life is probably more likely. Now, in that case, relying on water for carbon-based chemistry is likely to be a constraint, but it's entirely possible that the universe could surprise us. It often does.
Yeah, an excellent answer there, Elizabeth. I suppose I would just add to it is that from the fact of just not just looking at planets, but actually looking at moons, where there could be other things happening. We're looking at what's happening under the surface of Titan, and and others, you know, our own solar system. So, you know, when we're looking and checking these things out, I suppose it's looking at different locations, not just, well, what's actually happening on planets. But yeah, like who knows what a extraterrestrial creature could look like with the variety of biological life we have here on Earth and the conditions that they evolved to. What could it be like on some alien world where the chemical composition of the atmosphere is ever so slightly different? It'd be very exciting to sort of work that out, really. But we may be looking at it in the wrong place if it could be on moons around planets which may not necessarily be inhabitable zones, let alone the planets themselves.
Yes, I agree with that. And Europa is another really good candidate as well that I know a lot of space scientists want to explore Europa as well as Titan. Jason Gilchrist's question sort of ties in with this subject as well. He says, thanks for the fascinating presentations. It's very nice of you to say so. Jason, given that the science expectation is that life on Mars, if it exists or had existed, was microbiological, has microbial life been the source and focus of any science fiction about Mars versus macro life? Obviously, there's a microbes involved in life, War of the Worlds, but not from Mars, more from Earth.
From the other way around.
Yeah, a good question actually, because I'm stumped on that one.
I think I have one example.
Oh, go for
it. Well done.
The Doctor Who series special from 2009, Waters of Mars, involved a form of life which inhabited the water that people were drinking and consuming within Mars itself. And I believe that in that example, the organism involved was microbial, but I may be wrong.
That's very good. I like that one, actually. That's a really good one. Yeah, and of course that took over the host. It needed a host to be able to move around and do all the things it needed to do. So as another example of a different way of actually trying to talk about aliens taking over various situations and invading various places.
I must say we've had a couple of single word questions, but I think they may be suggestions for craters or ones or knowing certain craters that are also named on Mars after English place names. Somerset. Dr. David Robbins just said Somerset, so I think that's there must be maybe, well, that's a county, isn't it, rather than a place name, but and he also asked, if we could get to Mars, would the astronauts ever be able to return and blast off from Mars? Would it take 3 years to get there with present technology? Is that still isn't it still the case, I think?
I think it probably would still be the case. I think there are more talks tomorrow aspect of getting to Mars. So it might be worth asking that question again to tomorrow's speakers.
Excellent, very good idea. And let me see, I would have to say, David Everts, thank you for reminding me that when I was grappling to find out which film O.J. Simpson had been, and I thought it was the airplane movies. It was in fact Naked Gun. Yes, your starter for turn. But he also said that he thought that the labelling of a crater called Woking was obviously revenge for the Martians. Now we're very close now. We're 1 minute away from 7 o'clock. So I would like to say thank you to both Robert and Elizabeth, but also thank you to everybody who asked some questions. Sharon will be able to fill you in terms of what's happening next, because there's some quite cool stuff happening in the next hour. And Elizabeth, Sharon, well, yeah, definitely Sharon, Robert and myself will be around for a little longer to answer some of your questions. If we've not had time to do them now during the presentation, we will type them to in the chat room. So over to you, Sharon.
Thank you so much. I did just want to ask one more question, and that was just someone who asked right at the very beginning from YouTube, because our YouTube live viewers, they don't ping up on our screen, but it was such a good one that I just wanted to I might ask you guys, and I might also ask our next presenter for the Practical Astronomers, Robin Scagel, as well. So this one is, which sci-fi book or film is the most accurate? And that's from the 007 Harry, watching with us on YouTube Live. And I apologize that we missed a few of those questions from YouTube Live. But yes, can I go to Elizabeth first? Which sci-fi book or film is the most accurate for you?
On Mars or anything? Just on Mars?
It's a very difficult one.
I think wide-ranging.
I think that, yeah, I think The Martian has to be up there with this. Possibly also the 1950s radio program Journey into Space, which is a personal favourite of mine, and several others which were accurate at the time but may not be accurate now.
Robert, what about you?
Yeah, like I'm going to go outside of Mars and go for Interstellar, which is a brilliant movie, but mainly because it predicted, what a black hole, whenever you observe it, should actually look like. And of course, it's only in the last 2 years really we've had the EHT actually, give us the visualization of what a black hole should actually be. So like that, there's other things in there, of course, as well, and a lot of other things behind that. But for that specific imagery, I think it's incredibly accurate, really.
And the best name for a black hole ever, I think.
Yes.
Gargantua.
Gargantua, yeah. What else could you call it, really?
Exactly.
I've got one for the worst one that I have, which actually is a superhero one, and that's the one where Superman flies around the planet, Superman the movie, and turns back time, which I think is the worst possible thing that you could ever think about doing. So don't do that.
Okay. Sue, and then I'll come to Robin. You've got to give us your best, just to finish us off.
Well, I think, like Elizabeth, I think most accurate I've ever read is probably the Martian, and not least because Andy Weir is an engineer and has worked in the space industry, so that's understandable. But to be honest, I don't like my science fiction to be totally believable. So I'm a huge fan of time travel novels, and in particular a sort of an oldie but goldie, Jack Finney. He's one of those people that a lot of people don't know his name, but he's written Time and Again, which is one of my favorite. It's a time traveling novel set where people at the turn of the 20th century go back through a form of self-hypnosis in New York, and you never look at the Flatiron Building again without just thinking of that sort of wonderful romance. But he's also perhaps best well known. He wrote, there was a famous film. Was it not Invasion of the Body Snatchers? Was it Invasion? The one that, do you know what? That's really annoying. It's popped into my head and it's popped out again. But it will come to me as soon as we come off. Which film? Everybody knows. Maybe it is Invasion of the Body Snatchers. I think that might be the one that he wrote that people. Oh no!
Put it in the Q&A if you can remind Sue.
Was that John Wyndham? Which was the one? Oh, sorry, that's really bugs me now. But anyway, he's fabulous. So time travel for me, I don't care if the method of going back in time is believable or not. I want time travel, whether it's Star Trek or Doctor Who or say Jack Finney's books. I love time travel. So yeah, who cares? Who cares?
You hopeless romantic, you. And talking of romance and inspiration, we are moving over to the practical astronomers to get some real, we'll see what's up in the night sky tonight, see what we can snatch. Elizabeth, Robert, and Sue, thank you very much. Thank you so much for your time. And if you are able to spend another 10 minutes with us answering some questions offline, that would be brilliant, because we had floods of questions in. Robin, over to you with the question. Which sci-fi book or film would it be for you?
Well, I really enjoyed Gravity. In terms of actual realism, I thought that was way up at the top. Martian was pretty good. But Gravity, I only spotted one mistake, and that was where they were waving around in space on two people on the same tether. And it didn't work quite as I should have thought. But one thing is that some of the old 70s and 80s science fiction movies were actually used by NASA, I believe, I won't name names, as tests for their classes. How many mistakes can you spot? And most of them got up to the hundreds of mistakes in some of those trip to a comet films and that sort of thing. So there's a lot you can't believe in those films. Anyway,
that's it, and I think it's finding those mistakes as well that keeps us going.
Great fun, yeah.
Over to you, Robin. Thank you so much.
Thanks very much. Well, we've got some people lined up all over the country tonight. It's been a funny old day, hasn't it? It can't make up its mind whether it's going to be clear or cloudy, and that's what our astronomers are finding so far. We were hoping to show you the moon, and we might be able to show you moon from one or two places, but I'll show you where our astronomers are if I can just share my screen. I usually get this wrong when I try and share screen, but let's try this. Here we are. This is where we have astronomers at the moment. We've got Kielder Forest, Dan and Ellie up in Kielder Forest there, James Dawson in Nottingham, Ian Lawry's in around Braintree Way, beg your pardon, and David Strange down near Sidmouth. So that's where we are, a good spread of locations. And looking at the satellite map, it wasn't bad over the centre of the country. So I know that the Kielder and over down in Nottingham, it wasn't too bad. So let's try going over to Kielder and see what they've got for us. It was clear a short while ago. So hi there, Kielder. How's it looking?
At the moment, actually, it's just disappeared behind a cloud, would you believe? Dan had some really good views of the moon for just a few moments there, and it seems to have disappeared. But I think it seems like the cloud may be passing by, and hopefully we should get that back in another few minutes' time. So we should be able to show you something.
Right, and I know that down in Nottingham, James did have a look at some cloud. What's it like there?
We've just had a torrential rainstorm. Sorry.
Okay, and Ian, what's it like where you are in Essex?
We're looking okay. It's a bit of cloud coming and going, but we have actually managed to get a few things this evening already.
And you're on deep sky, aren't you? I think
I'm on deep sky, so I've got
objects, right?
cluster at the moment. If we want to have a look at that at some point.
Okay, and David down in Devon, there's a nice picture of the double cluster, I recognise that. David down in Devon, what's it like where you are?
Sorry, we're 100% cloud cover here.
Right, well, we'll come to you in a while anyway, and you can tell us all about what you're doing down there. Okay. But I think since Ian's actually got something to look at, let's go back to Ian, and you can tell us about that double cluster.
Okay, well, so what I've been doing is, again, I've been using my little telescope that I used earlier in the week. I'll show you a picture of it in a minute, but we're looking at the double cluster. Now, this is a nice one for people to take a look at. It's pretty easy to find, both with the naked eye if you've got a reasonably dark sky, and certainly with a small pair of binoculars, very, very easy to spot. So if I give you an idea of where to look, so approximately, I'll just switch across to my planetarium. I've got 20,000 things going on here. So if we look to the north and find the plough, which is down at the bottom here, and then we go up using the 2 pointers on the end up to the pole star, and then go on to the other side, you'll find Cassiopeia. So if you go out tonight, look up high, you'll see a W or an M shape, which is Cassiopeia, which is in the center of the screen here. And just below that, going back down towards the horizon, is the double cluster. It's right here. It's these two stars, two star clusters. There are two of them very close together. And when we look at it close up, you can see a very nice view of multiple stars in two clusters. Now I can give you a couple of facts and figures if I can if I can find the window with the right information. I have to read my script here, just bear with. And the double cluster, so getting this correctly, is about 7,500 light years away. There is the equivalent of in that area, about 20,000 equivalent of the sun, 20,000 star masses at the equivalent of the sun. So there are lots of stars that you can see, and there are quite a few different colors, some nice blue and sort of whitey ones and a few yellow ones. But the equivalent, including the ones you can't see in the image, because there are lots of faint ones, adds up to about 20,000 times the mass of the sun. So 7,500 light years away. Again, what I've been doing is I've been taking sort of about 6-second exposures, and I've managed to get 51 6-second exposures to make this image with my Astro camera and average them together in a process called stacking. I also have 358 exposures, which I've had to throw away, or the software's done it for me because the clouds rolled in. But if we have a quick look at the kit that I'm using, if I just whiz through, we ignore that for a bit. So this is the telescope we're using. It's the sort of yellowy one here. This is an 81mm refractor. On the back of that, we've got a filter wheel with colored filters in it, red, green, blue, and various other ones. And then we've got a black and white astronomical camera on the back. Now, because I can only take one filter at a time, we're looking in mono and black and white at the image. If I wanted to do a color image of it, I'd have to take several pictures with different filters and add them together. And then I've got my guiding scope up here, which actually helps to track. That's basically the setup in my little back garden observatory. I have got an Xbox controller for when I'm feeling particularly funky. I can drive the telescope around using that. And we've also got a motorized focuser. So the only thing I have to go outside for is to actually open the roof and close it again. Everything else I do from mission control. Right here, this is tonight's setup. I've got all the screens and more in the house. We'll maybe have a look at some other things a bit later on. So that's the double cluster that we managed to image tonight. So back to you, Robin.
Great, thanks. And if you want to find out where to look for the double cluster and you can't remember the show that the picture that Dan just showed, there is on the National Astronomy Week website a video which I did a while back showing you how to locate the double cluster, and there's plenty of things to find out in the observing tab on the National Astronomy Week website. That's astronomyweek.org.uk. So do have a look there and you'll find out a lot about it. And the thing is that through binoculars, you can see that double cluster, even in quite a poor sky. It won't look as good as the one that Ian has just shown us, but you can see it. So do take a look at that. It's really quite a nice sight. And if you've got a small telescope, one thing we're going to be talking about tonight is digging out those little telescopes that you may have stored under the bed. It doesn't matter even if it's a little spotting scope. Get your binoculars out, go and look at the sky, because there's plenty to see even with binoculars or with a small telescope. And that's one of the things I want to try and bring out. Now, Ian's been showing us his gear there, which looks very impressive, and I guess that is costing several thousands of pounds, but you don't need to spend that sort of money on your equipment for doing some astronomy. You can start with quite a small amount of money. Having said that, you might be surprised at something that although the telescopes, decent telescopes, have never been better value, I would say, if at the cheap end of the market, you still need to spend a fair amount of money to get something well worthwhile. If you were to go into a camera shop and buy a camera or something like that for about £75, you might expect to get quite a lot of quality out of it and take really good pictures. But a telescope costing £75 is really at the bottom end of the market. Why? It's because cameras are made, everyone's got a camera or they've got a phone, they've got masses of a huge number of sales, whereas maybe one person in 1,000 has bought a telescope, so the sales are much lower. So you do need to spend maybe £200 or £300 on even a reasonable telescope before you get some sort of quality. And I've actually been testing a telescope tonight that cost about £350, and I've taken some pictures through it. It worked quite well. That's the sort of price you would need to pay for getting a reasonable instrument these days. And I have to say that being Vice President of the Society for Popular Astronomy. I like to give a plug for the SPA. Our website is up there, popastro.com, and you can find a lot on our website about choosing a telescope, and indeed on the NAW website about choosing a telescope. Now, I gather that the moon has now gone in again from Kielder. How's it looking there, Dan? What's the latest at Kielder? If you can, Lucinda, if you can unmute Dan, and he can tell us.
Yeah, so it's still looking like it's a little bit of cloud on the horizon. So I think Dan's going to move up to Mars, which seems to be out of the cloud. So I think
We've got two Dans in Kielder, which is very confusing.
Yes, we do. Yeah, so we've got me, Dan, and then we've got Dan Monk as well, who's up at the observatory. I'm at home, which is nice. It's much warmer.
Yes, that is one problem with practical amateur astronomy, is that you have to brave the cold, but put on your warm clothes. As they say, there's no such thing as bad weather, just inappropriate clothing. So make sure you're well dressed up if you go out and observe.
Yeah, for sure.
And James Dawson in Nottingham says he can show the cloud and rain on the all sky camera in Nottingham. So, well, let's go for it. Okay, can we go over to Nottingham and have a look at the cloud and rain?
Okay, let me have a go. Can you see
Oh,
that?
my goodness! Yes.
So I don't normally have an all sky camera, but we've set one up in case there were nice things to see, but unfortunately we've had to put some cling film over it, so the view is a bit splattered with rain, I'm afraid, but this is just a normal planetary camera which has got a very wide angle lens on it. I think it's about 150 degrees wide.
Okay, well, we believe you. It's cloudy.
It's cloudy.
I think if we now go back to Kielder, and maybe you can, if you haven't got live stream at the moment, maybe you can show your video of what's going on.
Yeah, absolutely. Yeah. So I thought we could just we've got a video that we prepared some time ago of the observatory, and I think it just shows it in its nicest light. Just to give you an overview as to who we are and what we do. We are we're an observatory in the largest dark sky park of a gold tier standard in Europe. That's the Northumberland National Dark Sky Park. We're a public outreach observatory. That's majoritively what we do, is events that run 7 days a week, all the way throughout the year, apart from a couple of days at Christmas. And of course, during COVID, we've been closed and stuff as well. But generally, we're open 7 nights a week, run multiple events per year, and it's all for the benefit of the general public to come to the observatory, do some stargazing, use our big telescopes, and when it's cloudy, learn a little bit about astronomy and still experience the darkness of Kielder itself. And it's such a magnificent building and such an incredible facility that I don't think any description of it can really do it justice. So I've got a little video which I can play you, if I may, if that's all right. Let's play this video just here. Here we go. we do like a little bit of drama at the observatory, so that's us just there. Now, hopefully, Monk now has Mars, so we can screen share from the observatory. Dan should have a view of Mars through the telescope, and this is through our 16-inch ACF telescope. This one. And Ellie is also on the line, and she'll be able to chat to you a little bit more about Mars. Are you there, Ellie?
Yep, I'm here. Hello.
Super. Hi.
Hi there. Yeah, so I've been asked to come in and just talk a little bit about Mars and about this view of Mars that we're getting right now. So hopefully, something that most people should be able to see, or what we should all be able to see anyway, is that there's like a division of Mars. So the top half of it, of the northern hemisphere, appears to be significantly lighter than the southern hemisphere at the moment. Hopefully people can see that. And that's quite an interesting aspect of Mars, actually. So part of the reason for it, of course, is in the southern hemisphere at the moment, it's pointing towards the sun. So Mars is currently in summer. And as a result of that, the southern polar ice cap has quite a high concentration of carbon dioxide ice, which when it's exposed to solar radiation just turns to gas pretty much immediately. And that results in a fair amount of turbulent air. And what that turbulence does is it basically wipes clear the southern hemisphere from all the dust that sits on Mars. And the dust itself, that's the reddish color. So what we're actually seeing on the southern hemisphere is the dark basaltic rock that is actually Mars itself. That sort of reddish smoothness that you see on the top, that's really more dust with a high iron oxide concentration. But it's quite interesting because aside from just dust on the surface, Mars is almost quite literally divided in two. It's quite interesting. It's termed the Martian dichotomy. And you actually see that like the southern hemisphere of Mars is really pocketed. It's got loads of craters. It's quite irregular, I guess, whereas the top is sort of significantly smoother, even on geological terms. And the entire reason for that is, frankly, a bit unknown. It's one of those questions. There's a couple of theories, of course, but it's largely unknown, but it's quite an interesting aspect of Mars. And as I said, that southern hemisphere we're seeing, so at the bottom of the screen, the darker region, that's pointing towards the sun at the moment. And what you can just about make out, if you squint a lot, is a light region on the south of it, which is the southern polar ice cap. So the southern polar ice cap, it's bigger, obviously, in winter. At the moment it's summer, so it has slightly melted, but it's usually visible. And the most interesting thing about it right now, of course, is in July, actually, there was a paper published which seems to present data which suggests there's as many as 4 subglacial lakes, so like lakes of liquid, obviously, underneath that ice cap, which is an interesting discovery. It's an interesting thing when concerning stuff like life on Mars, because we should hope that there would be life where there's water. However, the scientists who published a paper about the lakes, they think it's a bit salty, a bit briny for life. And of course, there's also at the moment a dust storm on the southern hemisphere of Mars. Part of it being towards us and part of that turbulence that I mentioned means that it's kicked up an awful lot of dust in a dust storm that's in the southern hemisphere. I think it's around about 5 o'clock. I can just about see it as like a light region on the surface within the darker one that is the southern hemisphere itself. But that is what I'm able to see from Mars, and hopefully everyone else can see those aspects as well. I can just about see the dust storm.
It's quite turbulent, the atmosphere at the observatory now. Dan's just sent me a message and said gusts are up to about 30 miles an hour. So we've got some real turbulence around the dome, which is why it's jumping around and wobbling around as it is just there. But yeah, it still looks great. We can still see some really good features on it.
Yeah, no, it looks quite nice. I think Dan's doing quite a good job at keeping it still.
He's doing a very good, and keeping the roof on as well, I would imagine.
Yes, if I can jump in here, that dust storm we've been watching it throughout National Astronomy Week. It started, well, actually on the 14th, the first day of National Astronomy Week, last Saturday, a week ago, it wasn't visible at all. And we have had some really nice images from Agapios in Cyprus recently, and they're on the NAW website, and he's been tracking the dust storm. We've been watching it develop live over the days, and it seems now to have concentrated more on the South Pole. So it would be nice. I don't know if you've got the chance to stack one of that, some of that sequence there, and try and get us an image towards the end of the show. Are you starting to record now? That's good.
Yeah, he's
yeah, I just saw your mouse go over to the record button. So what we're doing now is making a recording of this sequence. It looks as if there's a bit of cloud going across, and with any luck you'll be able to stack that image and get a much better view. It'll choose only the very best frames. Looks like it's frozen there, and that will. We'll be able to sharpen that up quite a bit, so we'll have a look and see what that dust storm looks like. That's really good. Sure. Okay, I wonder if we can move on now, having had a look at Mars. Ian down in Braintree has had a look at some other things in the sky. He's looked at the globular cluster M15, which he captured earlier on this evening. So can we move it over to Ian, if you can unmute yourself, and if we can put the video on Ian. There we go. Over to you.
Hi. Okay. So a bit earlier on, about 6:45, so about 15 minutes before the talks ended, I was able to capture M15. This is what we call a globular cluster. So what we're actually seeing here is about 100,000 stars. It's about 33,000 light years away, and we believe in the centre of this one there is quite a large black hole. But it's one of the most tightly packed globular clusters. So all the stars in this sort of fuzzy ball are really, really close together. And if you were on a little planet somewhere in the middle of that, you'd probably be able to read your newspaper at any time of day or night because the sky would be so bright. It is located, again, if I maybe give you an idea of where it is in the sky, sort of wrong button, press button, so go. So it's quite a small one. There are some bigger globular clusters. But this one is just up from the moon. So if you kind of find the moon, which hasn't quite set yet, in the southwest, and if you find Mars, which is further around to the east and a bit higher, M15 would sort of make this big triangle shape that we can see. You'd need a small telescope to see it. There are lots of globular clusters going around the Milky Way. They orbit around the Milky Way. The biggest one we unfortunately can't see from this country, it's Omega Centauri. It's really huge and actually visible with the naked eye from the southern hemisphere. It's a really impressive sight. But there are a number of nice ones to look at. M15 is one of them. There are lots of other ones, but as I say, most of you will definitely need a telescope or a very large pair of binoculars to see. So that's M15.
Super. That is one of the few objects that really looks a bit like what you can see on the screen, and it's nice to see that through a good telescope. I must say that you can see it through binoculars, but usually the view through binoculars is a bit disappointing. You need quite a large telescope to show it like that, but the idea of seeing a ball of stars is great. It's a wonderful sight. Another word of warning really is that the pictures that you see of nebulae and clusters like that, particularly something like M15, often look a bit more bright, shall we say, than the view through a telescope. There is no telescope that can actually make them look as brilliant as they appear through on the camera. And when you look at a nebula or a galaxy through a telescope, even a large telescope, you may see it, but it always looks very ghostly. And if you do get that telescope out, don't expect it to show any colour on these objects, although those pictures we saw in black and white, but you see a lot of pictures in the sky which show brilliant colours. One sad fact is that our eyes are just not sensitive enough to colour at low light levels, and even through a large telescope, you very rarely see really see any color in the sky. But nevertheless, have a look. And one of the amazing things is, if you look at something like the Andromeda Galaxy, and we touched on this the other night, you're actually seeing something the light of which left it 2.5 million light years ago, or in the case of that globular cluster, many thousands of light years ago. And I always like to think, are there any aliens? We've been talking about aliens tonight. Are there any aliens looking towards us, looking towards our galaxy, looking towards our star, and seeing and wondering what we're like, and imagining what they might be like? The chances are that there is some sort of life form elsewhere in the galaxy, but that's another story. We've been discussing that over the last couple of nights, and last night's discussion also concentrated on that as well. I know James has still got rain in Nottingham, but maybe let's go down to David on the south coast and just have a chat with them. If we can bring David in now, David Strange down in Sidmouth. How are you, David?
Hi. Very cloudy here, and so no live imaging. But what I can do, I can show you a little bit about observing Mars and some of the features that we should be able to see. We've got probably another month and a half of observing Mars. So I can point out what the features are going to be as Mars rotates around.
Okay, go ahead.
Okay, so yeah, I'm based at the Norman Lockyer Observatory here in Sidmouth. Sadly, of course, we're closed to the public at the moment, but public outreach is what we're all about. So as soon as we all get vaccinated and this pandemic goes away, we'll be open up to the public. So what I had hoped to show you live images through my little telescope in my back garden, linked up with a little color imaging camera, but sadly that wasn't to be. So here's one I took earlier. This is a very typical image that you would see through a little 8 or 9 inch telescope with a fairly cheap imaging camera. And we can process that image and show some quite decent detail here on Mars. So what I'm basically going to do is talk about Mars, of course, rotates in 24 hours, 40 minutes. So each day it's a very slightly different phase. And what we're going to see is basically, if you're going to observe it every night at the same time, it will gradually rotate around. After about 36 days, you'll observe the entire planet. Now, I thoroughly recommend a wonderful little app available on the BAA website, the Mars Mapper app written by Adrian Ashford, that shows the features. You put in your time and it will show you all the features that are visible right now on Mars. And I'm guessing this is a sort of phase we're getting of Mars tonight. But don't be put off. If you haven't got all the high-tech equipment, you can start observing Mars. Now, this is one of those famous historical drawings of Mars ever done by Christian Huygens in 1659, and he's drawn a very distinctive feature. This is the famous V shape on Mars, the Syrtis Major. And by making that drawing, he was fairly able to accurately determine rotation rate on Mars, which he worked out as 1 day, 30 minutes. So let's start off with a pen and pencil. Observing Mars really does require patience. Don't expect to see detail at first sight. You need to be patient and catch those moments of perfectly still seeing. I've actually seen canals on Mars, would you believe it? This is back on October 88. I've been observing Mars for about 40 years, and I saw a little double structure, not one canal, but 2. So it is amazing. Even now you can see canals on Mars, but I'm guessing it was a trick of the light. These 2 dark features here on Mars, probably pointing in the same direction, tricked my eye into thinking that was a canal. But I can honestly say I have seen canals on Mars and I've drawn them. So from the 1980s, we invested in the early prototype Starlight Express CCDs from Terry Platt. Amazing little devices, but these are just single 75 millisecond exposures, but we could see more detail on Mars. Here I compared my image with a very shrunken HST image. So we were all very impressed by these little prototype cameras. Along came the Philips 2Cam Pro and the software to begin stacking lots of different video frames to improve resolution. And with this lovely color camera, we could see the blue polar hood and of course the red sandy deserts of Mars. Nowadays, of course, we have faster frame rates, smaller pixels and faster computing power, and it allows us to catch details unimaginable a few decades ago from ground-based telescopes. So let's explore Mars, the features you're going to see over the next month. We'll start with the Syrtis Major. This is the major dark feature on Mars, sometimes seen broad or pointed. It was originally called the Atlantic Canal by Angelo Secchi, who thought these two regions here were continents. So he imagined this to be equivalent to the Atlantic Ocean. But we now know, of course, it's a volcanic plateau. Above that, all my images are south of the top. I'm a traditionalist, so this is the South Polar Cap. We've got a big bay here. This is Hellas, originally called Lockyer Land by Richard Proctor, who did the first maps. Sometimes it appears brilliant white, so it looks like a polar cap, but it's a deep impact basin, probably about 3 miles deep, that can easily fill with white clouds. Right, so Mars is rotating around this way to the left. The next prominent feature we get is the famous Sinus Abaeus, which terminates in this feature here, Dawes Forked Bay, which marks a 0 longitude on Mars. That would be equivalent to our Greenwich meridian. To the south, we got the Pandorae Fretum, with Noachus above. Victorian observers often recorded a wave of darkening, suggesting a greening due to the growth of vegetation. I don't know whether we still see that. I've asked Richard Kim a few times, but no one's really come up with whether we do still experience this greening of Mars, or what that was caused by. Now, here at the NLO, we've got a wonderful collection from Lockyer's library. We've got a lot of the monthly notes, the Royal Astronomical Society, and I've dug out one, June 9th, 1865, written a report on Mars by the famous eagle-eyed Reverend W.R. Dawes. And in it, he writes about description of his forked bay, which he found with his Alvin Clark 8-inch, quarter-inch objective, giving the impression two very wide mouths of a river, which, however, I could never trace. This feature I've never seen depicted in any of the drawings of the planet. In Mr. Lockyer's excellent pictures representing his observations in 1862, that portion of the disc is repeatedly introduced, but never seemed to be divided. Lockyer always drew it as a club. So that's Dawes Forked Bay, which in this picture looks a bit blunted. It's probably been covered by dust over the last 150 years. There's a little indentation in the Sinus Abaeus. This is this huge crater, Schiaparelli. You can see it's a layered crater. And of course, Schiaparelli was the Italian astronomer who brought us the wonderful canali on Mars that led to Lowell's famous canals on Mars story. And to the north, we have the deserts of Eden and Cydonia. And of course, this is the area where the famous Face on Mars story originated from the Viking 1 images back in 1976. They saw this huge 2-kilometer long Cydonian Mesa. Also adjacent was this famous picture of the citadel, a walled city, and even a pyramid. And all the conspiracy theorists said this is evidence of intelligent life on Mars.
David, I think I'm going to interrupt you there because I think we can go to Kielder and the moon should be there if it's not there already. So sorry to interrupt you. Can we go straight over to Kielder?
Yep, we're working on it. We're nearly there. He's almost there. He says 2 minutes. So it must have come out. So hopefully we will have some moon for you in just a minute's time. Yeah.
Yes, the moon at the moment is just getting up to first quarter, and this is about the best time to observe the moon. And I must encourage people, if you've got that small telescope underneath your bed, do take a look at the moon, because it really is fantastic at this stage. You can see a huge amount of detail, and it will absolutely blow your mind if you've not looked at the moon through even a small telescope or even binoculars. Do so. So I did take some video earlier on, but if we don't get, looks like we're getting somewhere with from Dan now. Oh, look, there we go.
There we go. There's some moon.
I recognise that bit. Can you tell us what it is?
Yeah, Ellie, are you there? Ellie's going to talk to you about the moon. Hopefully she'll be able to identify this crater.
Hi, yeah. I picked this bit of the moon, actually. I asked Dan to go to it because it's a very small section of the moon that really has everything. In terms of what craters we're seeing here, the one towards the bottom, which has a little tiny visible mountain, well, not little, it's quite a big mountain, but it's got a visible mountain in the center of it. That is the crater Theophilus. Connected to it, you've got the crater of Cyrillus, and then also by itself, you have a crater called Caterina. And part of the reason why I chose these three is it's a nice example of lots of different craters, of course, but in particular, they're all kind of connected in a sense, because what I really love most about the moon is the number of stories behind it. And this one has so many connected to it. So in terms of craters on the moon, they're caused by impacts from rocks from space and stuff like that. Of varying sizes. All three of these craters are about 100 kilometers in diameter. They're all roughly the same sort of size. And Theophilus, that's the deepest one. But Theophilus and Cyrillus, they're both named for popes from Alexandria. And Catherine as well, she's named for a saint from Alexandria. Typically speaking, craters are named for philosophers or they're named for scientists. And there's 1,586 in total that are named for people. Of those 1,586, 28 are named for women. So part of the reason why I wanted to show everybody these craters, or in particular the crater Caterina, is because it's one of very few that are named for women, and specifically St. Catherine of Alexandria. But potentially the most interesting thing about Catherine, of course, is she may not have existed. There's been a lot of modern discourse over the actual existence of Catherine of Alexandria, and many people now actually consider Catherine to be pretty much the same person as Hypatia. Hypatia, that famous philosopher and scientist of Alexandria. So, if that is true, that means that Hypatia, as well as being, one of 28 women who has a named crater, she actually has two, and she's the only one who has two. And she also has the biggest crater named for a woman. And it also actually makes it a little bit awkward. It puts her in some slightly awkward company because Hypatia was sort of killed by Cyril in a sense. So that's a little bit awkward to be quite so close. But there are nice three sets of craters. And additionally, it's very close to these three that Apollo 16 landed. So as well as having three craters, you've got the landing site of Apollo 16. And also to the left of the screen, you've got the Sea of Nectar, which is one of those lovely dark regions on the moon, the Luna Maria. So an awful lot all in one little picture, which is why I wanted to show it to people.
Nice.
That's great. And we got there in the end on the moon. That's absolutely brilliant. And it's a very close-up part of the moon there. And you can see what we're faced with in terms of the way the atmosphere and the clouds, there they come, disturb the moon's surface, but you can see the rest of the moon there. It's really wonderful to look at. What I'd like to do now is just show you very briefly a video which I took of the whole moon a little earlier on. I mentioned earlier on that I was testing a telescope, and I think I can now show you the view from that telescope. There we are. I hope you can see that. This was one taken through a small telescope. It's actually a 4-inch telescope. It's one I only got in the post the other day to test. It's a Celestron 102DX StarSense, and this is the first light of that telescope, the first time it observed an astronomical object. And there it is, of course, the clouds going across. But you can actually see, this is on a loop, but when it comes out again, the 3 craters that Ellie mentioned there are actually just below the center of the disk. And if you, it'll loop through in a second, the picture will come up again. They are just about here. You can see them there on the video, Catarina Cyrillus and Theophilus. And incidentally, those are the first 3 craters ever to be observed on the moon. Not a lot of people know this, but when Thomas Harriot observed the moon in 1609, before Galileo, he actually, the first drawing of the moon he made actually showed those 3 craters. So there we are, the first craters ever to be observed on the moon. Now, I believe that we've got a map of the moon to identify some of those craters. So perhaps we can go over to James, who's got a map of the moon to show us.
Yes. So first of all, I was just going to show, that's it. I was just going to show how low the moon is at the moment and why we're struggling both with being able to see it, especially for me because there are houses in the way, but also as objects get lower in the sky, the seeing conditions get a lot worse. And I think we saw a lot of shimmering with the lovely Kilda images. Then I've got this, I've opened up this website, Quick Map, and this shows the moon in the current phase. We can see the terminator dividing lunar day and lunar night, and we can zoom in and we can see those 3 craters which Kilda were able to show us. And we can turn on the naming, and you can see there's Theophilus, and these are all on the western side of the Sea of Nectar, Mare Nectaris, just so you can see whereabouts in the moon. If you get a chance later, you can look for those craters yourself, although the moon is getting a bit low at the moment. So hopefully that puts things into perspective.
Yes, it certainly does. And one of the things is that this is a good time of the moon sequence to start looking at the moon, because everything starts to appear before your eyes as you watch. The moon is just before first quarter at the moment. Then night by night, a bit more of the moon is revealed. So if you can look at, if we keep that image on the screen, can we? Have we gone back to that image on the moon there? You can see the Mare Crisium, the first sea to appear as a crescent moon over on the left hand, the right hand side there, and then the other sea. Oh, there we are. That helps a lot. All the other seas start to appear, and as the moon unveils itself, you'll start to see other features. And it seems like there are hundreds. Well, indeed, there are thousands of craters, but by the time you've started to learn a few of the craters, you start to learn your way around the moon. So don't give up on it. Don't think there's far too much to see there. Even if you've only got binoculars, one of the tips is to make a drawing of the moon. It seems like an impossible thing to do, but you can do just through binoculars. Have a look through, say, 10 magnification binoculars, and you can see the dark areas, and you can see quite a lot of craters. So start to pick out which ones they are from a map of the moon like that, and you can very quickly learn a few of the bright craters as they appear. The ones at the top there, one's called Eudoxus, and they're not actually named. Can you point to, there Oh, there we go. Eudoxus and Aristoteles. Those are very prominent at this time of the lunation. Then, as we move on a bit further to the left of that, you can see a little plato called Plato, and that is a really obvious thing to look at. So, in the next night or two, look for Plato, and that will help you find your way. And the craters on the moon is a wonderful thing to look at, because as you watch the moon unfold, you see more and more details on the moon, and you can actually see, if you watch for an hour or so through a small telescope, you can actually see the sun rising over Plato and over other craters, and you can see small changes take place. The moon goes around the Earth once every 28 days, 29 days, and so sunrise takes a long time to happen, but you can witness these things happening as you're watching. So that's the moon, well worth observing, and that and Saturn, I think, are the two showpieces of the sky. We've got a few minutes left, so I'm going to go back to, if we go back to David Strange now, who we interrupted in mid-flow. So, David, can you pick up on where you were?
Yeah. Let me see. Let's go. I think, yeah. Okay, yeah, we were on the Face on Mars story. Can you all see that?
Yes, I can see it. Yeah.
Yeah, great. Okay. So yes, Face on Mars story lasted about 20 years until, of course, Mars Global Surveyor took more detailed images revealing the face on Mars was simply an optical illusion, or an example of what we call now pareidolia. So no ancient civilizations on Mars. So now again, the Mars is rotating around to the left here, and the feature we've got coming up now is this wonderful, it looks like a clubbed fist with the knuckles here. This is the Aurora Sinus, the Bay of the Dawn, coming into view. We've got Mare Acidalium, this dark area down below. And of course, the Viking landers landed here in 1976. And this is where the more recent dust storm originated from before spreading around to the Mariner Valley. Also here is the famous Aris Valley, which was a big outflow onto the Chryse Planetitia, and Mars Pathfinder landed here in 1997. We all remember these wonderful pictures of this spacecraft that bounced on the surface of Mars. You can see the deflated bags down below with a little rover Sojourner that went around taking wonderful pictures of. Sent a daily weather report. I mean, amazing here. That looked like a sandy desert in Sahara, but look at the temperature, minus 67 degrees centigrade, with a pressure, atmospheric pressure of just over 6 millibars. To the south, we've got a big, another large crater here. This is the Argyll Impact Basin, about 1,000 miles wide. Like Hellas, it formed probably about nearly 4 billion years ago. Argyll was named by Schiaparelli as the mythical island of silver in Greece. Here's those other pictures I say were taken with infrared pass filter, so they're mono images. This is a color filter taken with a little ASI 120 MC, and this shows the stubby fingers of the Aurora Sinus and the plains of Chryse, the land of gold. As we move on round, mono imaging now, this is the famous Lake of the Sun, Solus Lacus, and Schiaparelli named the bright surrounding area Thaumasia Felix, the land of wonders. We get a lot of dust storms forming in this area here. To the north lies the great Vallis Marineris, the Mariner Valley, huge structure, 2,500 miles long, so that would stretch across the whole of the United States. And the Grand Canyon will be a little side tributary on this scale. And on the end of the Mariner Valley, you can just make out here this little dark knot. This is Noctis labyrinthus, the labyrinth of the night, a maze-like system of very deep, steep-walled valleys, and amazing spacecraft images here. Going on round, we've now come to the Mare Serenum now coming into view. And the area below this is the Tharsis Bulge, highly volcanic area, where we see all these huge Martian volcanoes. And these three, the Craus Mons, Pavonis Mons, and Arsia Mons, can be seen here. They don't appear in my image, but I know Damon Peach and other top planetary imagers have been imaging these recently. And this is the view, of course, we've probably got of Mars at the moment. The Mare Cimerium now coming into view. Olympus Mons here, just about to disappear around the edge of the Terminator. Schiaparelli named this Nix Olympia, the snows of Olympus. In reality, it's a huge dormant shield volcano that would cover the whole of France, probably about 3 times the height of Mount Everest.
David, can I interrupt you? I think we'd need to go over to Ian now. Thanks very much for that. It's shown us Mars very well. And Ian has now got... one of the things that happened during National Astronomy Week was the Leonid meteors, but none of us got to see any because it was totally cloudy. But I believe Ian can prove that they actually do exist. So over to you, Ian.
Yeah, okay, just to give you an introduction to meteors. This tiny little rock here is actually a piece of Mars that was blown off the surface of Mars by a big impact millions of years ago, went around the solar system for a while, and eventually wound up in Morocco. This is one of North Essex Astro's collection of meteors. Very, very small piece, but that's a genuine piece of Mars. We know that. Now, what we can do, even when it's cloudy, is we can actually do meteor detecting using radar. I'll just really quickly run through and show you how this is done. The basic idea is that we have a radio transmitter somewhere over the horizon where we can't pick it up. When a meteor enters the atmosphere, the radio waves actually bounce off it and we can pick it up, and we know there's a meteor up there because we can suddenly receive the radio station for a second or two. Now, the transmitter we use is this top secret space radar that the French military operate in Dijon. They use it for tracking satellites. Must have cost them millions, very high tech, very good. But we can pick up the signals using this antenna in my back garden. Cost me 20 quid from B&Q, made from copper pipe, wood and household electrical parts. Took about half an hour to build. And a little, you can see it there on the side of the observatory, and a little radio dongle, which just turns the radio signals into numbers for the computer. That's basically a digital TV receiver that's been hacked and sold on Amazon, about 25 quid. And the radar sending signals out into space. Here's a very bad video of it working. And any meteors that enter this yellow sort of donut shape that we can see here will be picked up, and we'll pick the signal up. So what we can get is we can get both the meteor entering the atmosphere, and this is the frequency of the meteor radio return. So when the radio waves hit the meteor, they get shifted to different frequencies depending on how fast the meteor is going. And as it's moving across our field of view, the frequency changes very quickly, and then it leaves a trail of particles in the atmosphere for a few moments that then continue to reflect the signal. We can pick them up all over Europe. This is one we got from the 6th of November this year. It was believed big fireball somewhere down in the Mediterranean maybe, and I picked it up in Essex. It was picked up in Germany. It was picked up in several places in Italy and in France as well. So very easy to do. We can also pick up the space station. Here's the space station. It's quite big, moving through the radar beam because that's what it's designed for, picking up satellites, but we only get the big ones with our less sensitive receivers. Get various different types of meteor coming through. When we get meteor showers, we get lots of them happening at once. And we can even count the number of meteors, and our average number of meteors over a couple of weeks here by hour of day. And you can see that there are many more meteors in the early hours of the morning than there are in the afternoon and the evening. And the reason for that is that we're traveling through space, and any time that we're facing forwards, out of the front window of the Earth, as it were. The meteors splat into the Earth, and when we go around and we look go around this side at sort of daytime, we're looking out the back window so they don't catch up with us. Here's one that I got this morning. This is probably a Leonid meteor. The Leonid meteor shower has been active this week. Some very bright, fast meteors. You can see the meteor coming in and a big meteor trail. And here's another large one. It's probably quite a big fireball. Again, about 4 o'clock this morning. And I have managed to pick one up this evening. If we go back to the live view, so here's one that we picked up at about 25 to 8. So during the presentation, here's a meteor that actually came through. So that's meteor detecting. If you look up North Essex Astro or look me up on the web, you should be able to find some videos if you want to find out more about how to do this. It's not a particularly difficult project to set up.
Smashing. So you have actually been observing Leonid meteors, although none of us saw them, and well, that's great. They don't look anything like the ones we see in the sky, but it's nice to know that they're still up there, and we didn't miss anything dramatic. So just a few. I remember seeing the Leonids back in 2000, and they were coming down quite rapidly, one every literally 2 or 3 a second at one point. Well, just to end, we've now got clear skies up in Kielder again, and I believe we've got the planet Uranus. So could we go over to Kielder, please?
Yes, of course. Dan has Uranus through our 16-inch telescope. We should be able to see it just coming into the screen now. Now, Uranus is really far away, so it does look quite small. And with the seeing conditions tonight, I guess it's not as stable as we'd like. But there it is, nevertheless. And it's for me, it's one of my favorite things to look at through a telescope is Uranus, because it is just what you expect it to be, a turquoise dot that's really far away.
I remember showing this Uranus through my telescope at a star party to a previous National Astronomy Week, and there was a small girl about 9 or 10. You get a lot of girls at these star parties, and they're all very excited to see things through the telescope, and she was absolutely delighted to see Uranus because she said it's her favourite planet. So it's way out there in the cold of the outer solar system, but it's glad to know that someone loves it.
Yeah, absolutely. 2.8 billion kilometers away it is right now as well. So it's pretty far away from us. But what I love about it also is that it's very different to a lot of the other planets, being on its side and such. And it's a really interesting world, I think.
That's absolutely super. And thank you very much for showing us some objects through the telescope. We've been throughout the week until now, we've been excited to see pictures from Cyprus of Mars, really clear skies. And yet I'm glad to say that we've had some clear skies here in Britain as well. I know Agapios is watching the feed, so he will be with us tomorrow night, we hope, and we hope he's got clear skies. So thank you to everybody for showing your skies and showing your views and telling us what you've seen in the sky. Remember, those of you who are watching, go out and look. The sky's up there for you for free to look at. Look at the NAW website if you want help on choosing a telescope or how to find objects. And thank you to everybody who's been showing us the sky, and also the speakers earlier on. Fascinating talks we've had. Tomorrow night we'll be back at 6 for the very final show of National Astronomy Week, and tomorrow night it's going to be talking about humans on Mars. Can we actually travel to Mars? When are we likely to actually get there? Will the Martian become a reality? That's the question. So we will also be doing a viewing after that. So between 6 and 8 tomorrow night. Hope to see you there. And thanks very much for watching. Bye, everybody.
Thank you, everyone. Bye.